Vicky is here, and I'm BD manager of BIM. So first of all, welcome all of you to join this webinar. And today, the CYPE plumbing system is launched officially in Hong Kong. We are very excited and looking forward to the new chapter with CYPE. So the other good news is our CYPE plumbing system is pre-approved by CITF, which means the system is certified by the government that it can help improving the productivity in the whole project life cycle. So today, this webinar will have 3 parts. The first part is held by my colleague, Mr. Wilson Lee, for letting you know some CITF background and the collaboration between CYPE and BIM. And the second part is the CYPE plumbing system. It will hold by Ms. Maria and Mr. Pearl. And the last part is Q&A session. So please feel free to raise some or text your question in the chat box. Yeah, let's get started. So welcome, Wilson, please.
Okay, nice to meet you. Thanks for coming for watching the webinar for Chris. And okay, now change to the.
They can see the screen.
Can you see the now? You can see the PowerPoint now. And okay, so first welcome, and then we would like to explain a little bit. Okay, this is I'm Wilson for BIM. I'm also the BD manager. Okay. And in the past, okay, in our industry, in the past, we also used the paper to do everything. So paper will cause some projects for late and some tight schedule and something else. So this problem we caused over for many years. Now, in these few centuries, the building and construction industry already passed the 1.0, and now it's towards to 4.0, which means it's more everything should be automatically with the digitized and big data. So like other countries, they also do the same things. So you can see the chart, and many countries they already do some BIM jobs, and also in Hong Kong government also encourage for BIM for the industry and for some workshop for some BIM applications. So for BIM, we established for 2010. We mainly do the BIM modeling and consultancy. And on 2017, we have an investor, it's Zicheng Groups, and this is LWK Partners, an architect firm, which is 31 ranking in the world. And on 2018 to 21, we also have some new companies to join us. Okay, but there are some companies which for some drivers we develop ourselves for digital platform, and some is for BIM library, and some for software solution and RFID, and so on. Okay, our company, we have many offices in the world and in the Asia Pacific area, and we built about 1,000 jobs for the last 10 years, and we have about 30 staff in Hong Kong and the world. So what we are doing is mainly for BIM modeling and consultancy jobs, and also BIM training for some consultancy tenders and for customers. We provide some training for BIM applications and also CITF approved some customers in Hong Kong. And also we have driver's digital platforms we develop ourselves. It's mainly we stick for some projects like this. This is our platforms. And we also have some CDE and some applications for others like the eForm, some eForm system and some digital twins monitoring systems. And for last year, we started to have some robotic solutions. And this application, and we also have some robots in the CIC council. This is some iconic BIM products from our side. So we can see some iconic in Hong Kong. And we have some client base developers and contractors, subcontractors, and some architects. So we also is a reseller, except Autodesk. We also is now reseller for the scripts. Perhaps Now, SIPE is in for 1983, and they are mainly to develop and distribute technical software for architects and engineering firms. So for SIPEs, we mainly talk about for the SIPE plumbing systems. For these plumbing systems, we have sanitaries and water systems, two categories mainly, and so you can see there are different structures, and also they are available for reverse architect and also appliance. And the good news, just like we informed before, if we already successfully applied for the CITF funding, so applicants can enjoy more benefits on it. Everybody know is for CITF, the government encourage for some industrial technicals for 1 billion fundings. So applicants just simply to apply, and then they can enjoy for the products and also for training, 2 sessions for fundings. So for the ceiling for the software, it's about 70% for claim from the CITF fund. And now for the next step, except this plumbing system, and Clips also have the size cat, which is like the reverse first, and also have the 3Ds. So this like the reverse, but much more better. So next time you can enjoy it, and we are on the process to launch it. Just a minute, and we can start. I can pass to Maria and Carlos.
Thank you.
Thank you.
Good morning. Hello, my name is Maria Adrià. I'm an industrial engineer and work in the technical support department at SIPE. Let me check if I can share my screen, first of all.
So I'm showing here. I have opened some buildings, some hydraulic systems made with this program. Only to show you some possibilities. My computer is not too good, like Maria computer. It's not too good, so to move this kind of buildings, this kind of installations, maybe has we have a little problem. We have a little minutes to establish all the installation. In this case, this is 75 building houses. So this is a little installation that we can do in water supply. Okay, so the program will be based on IFC standards, so we can import IFCs from the architecture model from programs. I see that you are seeing now. Okay. We can, like I was telling, we can import models from IFC Builder, CP Architecture. There is modelers in BIM solutions, and we can establish here the hydraulic systems, like the pumps that we have, the pipes for all the floors, and we can do all the dimensioning using hydraulic calculations, okay, and applying standards. In this case, in 1 hour approximately, we can see it alive, doing it, a little installation, so you can see in alive how this works. Okay, so this is water supply. For instance, we can analyze in a quick way the parameters of these installations, and in these big installations we can see if we are making some kind of mistakes. Okay, let me put here. Okay, the program will advise you, will guide you with the errors, with warnings, so you can see if you are making some kind of mistakes to establish a minimum quality that you provide to that you have to provide to the installation. Okay, the quality, what I mean with quality is the minimum pressure on the consumptions, velocity, not using higher velocities that the standard indicates. So every point you can the program will advise you, will warn you that we are establishing some kind of problems. Okay, first of all, I have to apologize myself because of my English. I'm Portuguese. I'm working on CYPE software company in Alicante, is Spain. So I'm Portuguese, working in Spain and talking in English. We can have some problems, okay? So I just now I want to apologize myself for my English, okay? So let's it's taking a little bit, because the program in this case is using iterative calculations. The program will provide the less pressure needed for the pumps. For instance, we will use the program can use a minimum available pressure requirement, minimum diameter. You can establish many kind of parameters, so you have a good installation. See, the program will advise you if with warnings and advices that you are making some kind of mistakes. Okay, so for instance, the velocity, if you let me see now the 3D the 3D installations, so you can see this kind of analysis, graphic analysis, not only in the 2D dimension, but in 3D you can analyze what kind and what parts of our installation has more velocity or the minimum velocity. In this case, you can analyze in only one view a big building. You can see the parts of the building that maybe we have to check and we have to change it, so you can improve the quality of our installations. I'm talking about velocity, but I can talk about pressure, minimum pressure on the consumptions, the pressure on the pumps, all of these parameters that are very important, so we can have, let me take off the architecture model. So we can we can establish a good quality installations. You see, now here you can, if you go near, you can see the flow where it goes and the velocity, in this case more velocity, less velocity. So in a view, in a little view, you can see where the problems are in 3D and 2D. Okay, so this is very interesting. One moment, please. Okay, so this is it.
Well, we would like that you know how we began and what is CYPE exactly, because we have a very interesting story, really. We started in 1983, actually as an engineering company, doing structural analysis. And as we developed bigger and bigger structures, instead of working with manually by hand, or we started developing computer programs in order to do our own calculations. But then, as these programs got quite interesting and we thought it could be useful for other people, we started developing for for a variety of users. And actually, nowadays is our main activity, developing programs for different calculations. We have more than 140 programs, so you can imagine the wide range of programs we have. And as we have been so many years working with these programs, the results are really reliable, and we always try that our programs are really user-friendly. And well, you will see today, I hope, you see that once you have learned one program, it's quite easy to learn the rest of them. We try that they are quite similar and as I say, easy to learn, user-friendly. We are a Spanish company, but we have spread all over the world. We have more than 70,000 users located in more than 60 countries. So get an idea of how spread we are, and we have. Let's start this travel around the world. How we started in Spain, as is our country, and we have developed programs that have been validated for official calculations of thermal analysis. We're very, very proud of that. This has happened in Italy, France, Portugal, and Spain. Are term programs, programs that use EPLOS engine. Also, we have made an agreement with the most important technical institute of France for acoustics, the CSTB, and in addition, we have developed a SICA software for calculating carbon fiber reinforcements in the structures. In Latin America, we have more than 15,000 clients. Is one of the most used software for structures, building services, and management. There we have more than 20 distributors, and we developed a custom software for Repsol that is for calculating gas installations. And also we have land in the USA. We have presented the SciTherm programs, the SciTherm suite, and also the structure suite that is called StruBIM. We were in the USA in 2016, presenting in some programs in a variety of congresses. And we even have headquarters in Atlanta. We have presence also in India, Australia, etc. Also in Africa, especially in these countries where they speak French and Portuguese. And well, last but not the least, Hong Kong, and that's the reason we are holding this webinar today. Is this our very recent goal that has been to reach an agreement with you with the CITF, which supports the use of plumbing water systems and plumbing sanitary systems as you promote technician productivity and raise project quality by following sustainable criteria. You afterwards will see that we have very common goals, and well, we have been there and have a good relationship. Well, talking about our goals, the goals we have with our plumbing programs is that the installations we design have energy efficiency and also have or give comfort to the users in terms of the flow, the pressure, the acoustic comfort, of course, talking about the different dimensions or the slope of the conduct of the different parts. And of course, it's very important that the installation is economical. After all, the economical part is always important. So we help the designer to get a low maintenance and low energy bill installation. These programs not only calculate the installation, but also generate the bill of quantities. Let's take a look a little bit about the workflow, the BIM server workflow, because what our main objective or our main goal is that all the agents that work in the project are together in our platform, in our BIMserver.center platform. In this, for example, some of the agents that can work in this are the architects, the engineers, and the constructors. In today's webinar, we will try to show you this because I'm going to do as if I were the architect that playing that role. So then I'll start with the architectural model, and then Paulo will continue as an engineer doing the installation, the plumbing installations. And then talking about the constructor is interesting because we also want to do the final, that what we calculate is the final installation, with the real pieces, etc. And that we have so many programs that do that. And in particular, today we're going to talk about Aliaxis. And well, I hope this is understandable when we do the example. Let's take a look a little bit about this scheme, because it's important to see how we suggest that the different steps are taken. Okay, the first step is to have an architectural model. This architectural model it has to be in IFC format. You know that it's an open format. We work with open formats. The results are in open format. So we start with an IFC file, which is the architectural model, and with this file we start the project. That project will be saved in the cloud. In this case, in our platform, BIMserver.center. Okay, so that's the way. If you follow this arrow, is the step of uploading the file to the platform. Then this model will be available to all the work team. Okay, because really this platform is a social network actually, allows us to invite different participants to the project. So each specialist will do its part. So for example, if I have a plumbing expert, that person will download the IFC, use the IFC in order to continue with the different applications, in this case, the plumbing applications. And then when that part is finished, they can export the results to the platform again. So in the platform, we can see the 3D, for example, and the different results. Okay, this is more or less the workflow. Let's go in more detail. Okay, I see that. Let's talk about the first step, how we make the IFC model. Actually, there are many ways. These two programs, Site Architecture and IFC Builder, are programs that we have developed, are SIPE programs. SIPE Architecture is a modeler in which you can start with the sketch and then make your architectural model. Okay, or you can also use templates, but it's thought when you are thinking about the building from the beginning and you want it with a lot of detail. Then this other program, IFC Builder, this is the program we are going to use today, which is a very, very easy to use program. You can go really fast, and especially if you already have the templates, the DWG templates, you have them, you can create an architectural model really fast. Then another way in order to start the project could be, if you have a Revit license, you could install the plugin Open BIM Revit and then start the project from Revit. And in addition, there is a translator from Allplan, or in this case, so there's a translator from Archicad to CYPE. And also, if you use other programs or the IFC, they have given you the IFC, but you don't have the license of that IFC, the last option is to upload the IFC with IFC uploader, and then continue with the rest of the applications. Well, as I said, today we are going to focus on IFC Builder. Okay, which is very I usually use with the WG or DX files, also with images, but more better with CAD. It has a 2D environment and generates a 3D model. So the result is in IFC4 format. I'll show you later, okay? That's just a quick presentation. Just in case, talking about IFC, we work with this format because it's an open format. So all programs will be able to read them. This is how the BIMserver.center looks when you have a project. We'll talk later about that. Just a quick review of the programs we are going to talk about today. Imagine, as I said, you have the architectural model, and then what's the next step? The next step could be to insert the water requirement, the sanitary appliances, with this program with Open BIM water requirement. Really easy to use program. I'll show you later, but it's again in 2D, but gets a 3D, and also you get how many appliances you have, a list, a report of how many elements you have used. Then the main programs we are going to talk about today. First of all, Plumbing Water Systems. This is a very powerful program. Of course, with BIM connection, which means that it's ready to read the IFC, so automatically reads the levels and sees the IFC. So you here only have to create the pipes and the elements of the water installation. It's very it's very configurable. It has a preset of parameters of different standards, but of course it's editable. You can create your own parameters. Okay, so it's helpful because it is not empty at the beginning, but it's very easy to create your own parameters. In this program also you insert the elements in 2D, but the results are in 3D, and it has a lot of tools for interaction. So, for example, you can see the flow, or you can even say after you have calculated, because the program does the hydraulic analysis, and of course determines the flow, pressure, velocity, etc. in every span. So afterwards, you can get as you can see here, a graphical analysis of the results in the 2D and in the 3D. So it helps the designer. Okay, the results are the reports are very complete and also personalized by the user. Also, you get the plans that you can, of course, print directly or export in different formats. Okay, from CAD programs. Okay, let's talk about plumbing solar systems. This program is for the design of solar thermal collection installations. Again, this program is connected with the Open BIM workflow, so it reads the IFC from programs I said. So you just insert the installations. And of course, in the 3D, that is very helpful. You can see all the, for example, if you have already created the water systems, you will see it in the 3D. So it's very helpful. Also, it has configured parameters. The user can configure their own, not only the materials, but also the checks that are going to be made. And this program has a 2D environment, but generates the 3D. And gets very complete reports and plans that can be printed or exported to different formats. The other program we are going to talk about is Plumbing Sanitary Systems. This program is aimed to calculate the design of wastewater and rainwater installations connected with the BIM workflow. It has presets of different standards, but allows the user to configure its own criteria. And of course, creating new discharges, etc. Really, well, very complete. If you take your time giving information to the program, you will get really, really interesting reports and checks. And well, the last program, the Open BIM Axis, is, as I said, a vendor's program with which you get with much detail the real pieces of the installations. In this case, of this brand. Okay. Paulo has already shown this. And well, that's it. That's all the presentation. Before I move to Paulo, I just would like to show you a little bit an example of what I meant by the architectural model. Okay. First of all, I'll open this. For example, just a little example of a file created by CYPE architecture. In this case, this program has, as I said, three tabs. You can start with a sketch, then create the architectural model, and then add the furniture, which includes the sanitary appliances. In this case, I'm going to show you well, how, for example, in this floor, we have added the different sanitary appliances. So these elements will be read by the site planning programs. So they will be exactly in that position, and well, that saves so much time. I think that's a brief example of this. And for example, with IFC Builder, this is different this has a 2D environment. You work directly in plans, but of course you get 3D view and export an IFC the same way, and you are able to continue with the rest of the programs. Okay, now I'm going to show you a real example of how we are going to, well, from Paula and I are going to do a real example of how to do a project, so you see how easy it is and how works the workflow. Okay, what we mean by beginning a project and continue with the rest of applications. Okay, so let's do this. Okay. First of all, I'm going to. I'd like to show you the platform is BIMserver.center. make sure to choose the right flag you're more comfortable with, okay? And of course, if you have already an account in BIMserver.center, just log in. In case you haven't already logged in, first click in register, okay? Then I'm here in my account, and let's do a new, okay, here I have the projects, I have recently participated, and let's create a new project. Here, I give a name to the project. Example, let's see, on and the date of today. To be plumbing, order, and let's make it visible to all users and open to collaboration requests, because it's one of the goals of this, that everybody is in contact, so we can invite people to our project so they can continue the different tasks. So let's do this part, create a new project. And now I have an empty project. Okay, afterwards I'll show you how this is going to be with more information. Okay, now it's empty, and I'm going to invite Paulo to the project. How can I do that? Very easily. I'll go to the work team tab and invite a user. I have created a group that is called the plumbing team, in which Paulo is. So very easily I include him in the project. I'll give him all the permissions, and I'll ask him to do the wastewater installations. As I'm going to do this, please complete the plumbing installations. He will receive an email with an invitation to participate in the project. So, okay, let's start with that part. This is done. Okay, another important thing, of course, is having the synchronizer working. Okay, see this. BIMserver.center synchronizer working. Okay, now I have this model. This is the architectural model, and I'm going to start the project with this file. So what do? I'm going to link this file to the project, and then export. Okay, so he will get the architectural model. Accept. Okay, so now that this is done, okay, in this will be uploaded. So he will be able to continue. Okay, so let's see. This is uploading now. Okay. So now that this is done, well, maybe this is Paulo. Maybe you can continue.
Okay.
Is it okay? Should I give you the permission, or you can do directly? Okay. Now, as he has received an invitation to the project and has to accept it. Okay. So now the one thing you can see here the architectural model that I have uploaded. Okay, so even, for example, something interesting is that I can invite somebody to just see what I have done. For example, in this case, Paula is going to continue, but sometimes you just want to share the results with somebody, etc. Okay, this is by what I did. We get the WG, the IFC, that you can share. Okay, I'm going to make you the hoster, Paulo. It's okay?
Okay.
Okay.
Thank you.
Okay. And as he does this.
You are seeing my screen?
Yes, yes. We can see a 3D view of an
Okay.
installation. Okay.
So let me show you here. This is how I receive his request, his invitation, the invitation. This is Maria. And in the part, when we enter BIMserver.center, we have this configuration. So we have project, store, and collaboration requests. The collaboration request, sorry, I have many windows open. So I have to accept it, okay? I don't know. It's from Maria. Maybe I rejected. No, better.
Please accept me.
Okay, if you tell me this way, I accept.
Okay.
So now I'm going to the project, the project part, and I have already, you see, my computer with the help of the synchronizer it started to download the information. Okay, so she is in his home and I'm in my home, as you can see, because of this situation, pandemic situation. No? So I received the information and I can start working and I can start using this model. The general idea, and I'm going to start where Maria was finished his presentation, is the general idea is that I receive the model, then I export the plumbing installation, in this case water supply, then as you can see the wastewater installation, and then I can add, as you've seen in the presentation, the solar systems, and so on, like sprinkler systems, gas systems, and then with the help of the many applications on the store, we can convert all this information and do the clash detections between the installations in the structure with the architectural, and we have here applications that the model checker, open BIM model checker. Then we can also have other application, like let me see. Let me put here all the applications. For instance, we have, like you see in the presentation of Maria, we can have the plans, the basic plans for the installations, water supplies installations and sanitary wastewater plans. No, but we can add information to this project, like when we export all the information, like as you see there, when we have all this situation, we can do like the clash detections with the model checker. Let me see where it is. There's open BIM model checker to see the clash detections. So when you see the workflow on the presentation of Maria, you saw that is not static. You can go and export again and see the class detections, go again, and until we have all together, all fixed. So we can have, like as you see, applications to do this question, the class detections, and also we have other applications to do to apport, to give to the plans or to the project more information with the plans, doing it, the plans together with installations, with the structure all together and do information, so we can execute this project so well done. No, we can execute from the better way to execute is having the more information, the class detections did it, and a real good plans. Okay, so we have the tools to do it. So we are going to see first of all plumbing installation, but I wanted to you get the general idea that we can in this workflow having more information and see it all together. And also like I think is Kim that talk in the in very first beginning that digitalizing, no, the problematic of digitalizing the sorry is we can also above all of these things that we have now, all the plans that can be digitalized, all of this we can, with only what you are going to see, what you are seeing exporting to the cloud, we can install these applications to see your project in reality, augmented reality or virtual reality. You can take the installation to the ground, to the place where it's going to be, and explain to the engineers, to the people that is going to take the installation to the real thing. So you can explain by using not only plans, but digital plans, but also augmented reality or virtual reality. You have to think about that. I don't have to do anything more than studying, like I was showing you the installation, drawing the installation, applying standards, applying the best job possible, the best way, the best flow possible on our hydraulic installations, using engineer mentality that solves questions, solves hydraulic problems, and we have only to think about this: the real, the virtual reality and digitalizing the plans. And it's done. When you do, you have to think about what the problematic is. That in this case is hydraulic problematic. For instance, in the beginning I show you a model from the model from water supply. For instance, in this case, you are going to see the wastewater problematic, no? But for the same project, you can see these projects if you install the programs. You can see these installations in examples. Okay. Also, this webinar is we are telling you many information, too many information maybe, and it's important that you know that this webinar are being recorded, so you can then later see it again, okay, and take some advantage of or more advantage of this webinar to use these tools. Okay, you see, this is the installation on the same way. You can see the flow, you can analyze the installation, you can have graphic analysis also. Like Maria was telling in his presentation, when you know how to work with one application, the other applications, as you can see, is very similar to work. So you don't have to be afraid. You have to focus on one application, study it, and when you study and know how to work with this, you can work with the others. Okay, maybe I can show you where you can have more information to this. When we entered the store of the BIMserver.center, we can go like I'm saying that in this webinar they are putting the manual information. Okay, so when you go here and subscribe yourself to this store, we can I'm seeing that it's going a little bit slow, the connection, but we can go, for instance, at the CYPE Plumbing Sanitary Systems. We can have here available resources, and we have the seminars here. Maybe some ones are in Spanish, and free plumbing tutorial in this case is in English. Okay, the manuals in this case is in Spanish, but we have it in other. But we have here in some kind of information. Other forms is like I'm showing that you in examples and in projects we can open here, and when you open files you have examples that you can see how it's doing, how it's using it to do some kind of installations. So to show you a bigger installation, I was already open it because it's incredible big. So we have here, for instance, the calculation of a collector for a pipe. You see, it's very big. This, in this case, is 25 floors above the ground and 4 floors under the ground. So you see all the verifications of all the checks from using design tables from the standard and using the hydraulic analysis. Basically, the standard, in this case, I'm going to use in the real presentation, I'm going to use a standard, a British standard, so you can have an example. But you can see that we have all kinds of checks to use in each part of the installation. You are going to see. Let me show, for instance, this project is more or less, if you see here, 4,549 square meters. Okay, so but above the ground we have 3 floors, but above the ground, if, as you can see, my computer is not prepared to these big projects. I hope, I'm certain that that all of you have better computer than mine. This came from a big a great engineer here in Spain that has big buildings. So he let me show you only these pipes of the building. You see, this is taking a little bit because it's like I told you, it's 25 floors, is more or less a big building. So it's important that you have good computers, not like mine. So when it's wait, wait a minute. Let's see if it is starting. Let me take off information here, so the program can. I have too many projects open, so let me give more space to this computer so it can have more memory to, so I can show you this project. One minute, sorry. I'm seeing
Pablo,
that nobody. Okay,
Pablo,
tell me.
maybe could you check if you have received what I sent you?
For where?
You should have the architectural model.
Ah, no, I have it. I have it. I
Have
already
okay,
have it.
okay, okay, just to make sure.
See, I have it. I have it already. You see, this is a big project. You see, there is the buried part of the installation. You see, with the slopes, you know, you can analyze the excavation, all the installation. Okay, so you can see how powerful it can be, this tool. We are going to show you a little one, so only that you can see that is alive systems. There's no and the ones that Maria gave me is this one is a little example that I'm going to do it just now. Okay. So only to finish this, see, this model is a model from Open BIM Aliaxis. It's a manufacturer for pipes. If you see now is not a project, but is a real installation with real pieces. If you can see, it is, you can in project in your computer having this kind of information all done for the installation could be well done on the reality. Okay, so you can have this and take this to the virtual reality for installation, doing it starting for the calculations. If I put here the pipes, in this case I am receiving the pipes calculated from can it be from CYPE Plumbing sanitary systems, that is the better this workflow, but we can receive in IFC a model calculated and imported on this manufacturer manufacturer of pipes and we can do it making it and change it a little, so we can put this project to the real thing. Okay, I don't know if I'm explaining myself. I'm seeing that nobody is putting questions. I hope that you are understanding. Oh, like I told you, this is being recorded. I hope that you can understand all of this. Okay, but this is the real thing. Okay, so from the projects like you see before, this in this case is a project for 40 houses, around 40 houses, I think. Is a little project, also is more or less little, and you can transform, you can I'm an engineer, I'm a civil engineer, and my preoccupation is that the hydraulic system is well dimensioned, it works well. So I'm going to start my preoccupation, and my concerning is doing these hydraulic calculations, and to achieve this kind of installation is very easy. When the model is done, this is automatically. You are not going to take many time to do this. If you do a well done project, maybe 90% of the pieces in the pipes, the real thing, can be done in seconds. Okay, let me show you. So this is the project that Maria sent me, and I'm starting for using CYPE Plumbing water systems. I'm going to take the information that Maria said, water systems. I'm saving this file on my computer. The only thing that communicates the interoperability that I'm making now with the Maria is with IFC files. Okay, so I'm going to select the project. You see, this is from today, so I am accepting the project from Maria. And you see, she put at 9 in Spain, 9 o'clock, more or less, the initiator, the IFC builder, the architectural model. She's taking the role from the architectural role, okay, and I'm in the engineer role. So I'm now taking information, from this model. I have already receiving information, and this is the heart of I like to tell this, because for me this is the heart of the program. If you understand this, you can understand all the programs of all the CYPE Plumbing programs. So here is very important. In the beginning, you can establish your libraries, okay, your material and equipment selection, your design and check options is all starting from zero. Okay, is because of this that the program can be used all over the world, and we are all over the world, okay? For instance, if I put, like, for instance, a manufacturer from Spain, I put his configurations, and I have some configurations with minimum nominal diameter, maximum velocity, minimum velocity, increases of the real length, okay, so the loss of span. So to analyze this, the maximum pressure loss of the span. So we can do a lot of configurations, like graphical configurations, the kind of material, general options for our installations. For instance, the thermal insulation is very important because we are going to lose temperature from the water heater to the consumption. So the program will calculate this loss of temperature because it's very important for the rendimiento. How do I say this?
One second in there. I'm looking for it.
The performance, no, the performance of our hot water installation. Sorry again for my English. Okay, this performance is not only depending of the water heater, but also the pipes. We have to isolate the pipes with thermal insulants, and we have to take this temperature to our consumptions. So this is a part of losing, like Maria was telling in his presentation, the energy efficiency depends on this, of the system of water, hot water installation. Also, it depends in this, if you going to have a mode calculation that the program will increase diameters when the program can increase these diameters, and in the iterative way, it can have our installation with less energy to take the water from the beginning, from the pumps to the consumption. So this is energy efficiency too. So for instance, Maria was talking about acoustic problems. If we limit the velocity of these pipes, we are going to have maybe better installation, better acoustic on our installations. Okay, for instance, comfort to achieve this pressure, this minimum pressure on our consumptions. This is comfort for the users. Okay, so the thing is, the whole workflow based on this, starting with calculations with a graphical program. In the beginning, you are seeing your concerning is to do a well done, well design of our installations, to have energy efficiency, comfort, acoustic, and pressure and flow comfort for our users. And also, like Maria was telling, we can have the bill of quantities and analyze if I can put a pump, a bigger pump, or less diameters, and have these considerations. Okay, so in this case, we can have all of these calculations with the simultaneity, the iterative calculations. We can work, okay, with the temperature of the water and analyze the heat dissipation. Okay, all of this we can do it to have efficiency, the hot water demand, to dimension the water systems that we have to have. Okay, for instance, the storage tanks. If you are working with storage tanks, it's important to have the demand criteria, so to analyze what storage that we have to have. As you see, the ruggedness, the thermal conductivity. The general idea is that your concerning is to use the standard criteria, but you can establish your own criteria. Now you see is different criteria used. Now I'm using the British standard, but I can configure it. I can personalize these criteria because the standards they give me a minimum quality a minimum quality installation, so I can improve this quality or I can change it a little to have my personalized options. So I have here, I exported before, I work it out, and I have a personal configuration for my installations. Okay, so when you understand all of this, you can work. For instance, I'm used to using meter water column, but if you are used to another measures unit, sorry, you can use this and personalize how to work in this. Okay, you can personalize the type of line, the labeling, the symbology. For instance, we have some symbologies, but you can personalize and create your own symbologies. Let me show you again this very interesting. This manufacturer do a good configuration of the program. You see, for instance, he made the configuration of his own symbology. Okay, the program gave you one symbology, but you can personalize and use your own symbology. Is important for the plans. General checks, you can make some tell the program to do some advisings, some warnings when you are not established some kind of checks. No, using criteria with one click, you can change all the installation. Okay, you can change all of it. Okay, let me use again the personal config. Okay, so I have here MDPA water service pipe with this criteria, with this, I use one, but the important thing is in the very beginning, you can use a generical or pre-configuration of British standard or wherever you want, and you can personalize like I did and use a personalized configuration. Okay, it's very important. You have to do it in all the cases. For instance, accessories. In this case, I only put stop valves, check valves. Okay, but I can put T's, I can put elbows, I can put everything and analyze T's and elbows and all the accessories independently. Okay, I have questions already. Nice. Sorry, I'm working in the acoustic related field. Want to understand that after the plumbing system is built, how can the layout and data be integrated on CYPE Acrobat for further acoustic analysis of the plumbing noises? Okay, this is, thank you, Banting, for the question. The thing is, in the workflow, when you export the information, in this case, you are going to export the pipes, okay? And the pipes will appear there. You can import and see the pipes on your model. And when you start the Acrobat, you can see where the pipes are going, and you can isolate these parts of where the pipes are going to be careful, to have this question, to have this prepared, so we don't have the acoustic problems from the pipes to our spaces. No, so it depending on the pipes goes, you can see it on the CYPE Acrobat. Okay, so to analyze. Other thing is more technical thing. It was to receive the noise that the pipe does. So this is not for now exported. This technical information is not exported for now. You have to study it on CYPE plumbing, like using the only guarantee that you can have in CYPE plumbing is using lower velocities, not very low, because you can have problems below. But if you use low velocities, we can have less sound. It's the only analysis like technical analysis for the sound that we can have directly in CYPE Plumbing. The other thing is to use a pipe prepared. You see that manufacturers is more and more preoccupied concerning the in the noise of those pipes. So you can use also a good pipe that isolate your installation. You are going to see in sanitary systems also the concerning the preoccupation, no? Preocupación?
Concern.
The concern of the manufacturers on this kind of problem. But you can analyze this all together. Like I told you, you can see where the pipes were going, and in CYPE you can see it. You have the concerning here in CYPE Plumbing. You have to calculate here, okay? Have this concerning, and then in CYPE you can see where the pipe's going, and you can isolate more where these spaces, if it goes near the houses or if it goes in the garage or in the parking space, it's not a problem. But if you can see it where it goes and where to isolate more our installations, for instance. Okay, I don't know if I answer your question very well. If you are confusing, can we use the same
Paulo, sorry to interrupt. Maybe could you show us how to limit the velocity, for example?
Yeah, I did show before. You can have in criteria the maximum velocity. For instance, in the British standard, the maximum velocity permitted is 3 meters per second. I never did installation with 3 meters. Like I told you, thank you, Maria. We have the British standard, but we can also in between, in the middle of these criteria, because the standards only wants to have a minimum quality. I can improve this quality to changing velocity, for instance, at 2 meters, or at some hydraulic texts, some hydraulic books can talk about 1 meter per second. That is the optimum velocity, so we cannot have problems with the acoustic problems, for instance. So we can make in these parts, you can draw some parts of the installation, some particular parts that are between houses, for instance. We can draw some parts with 1 meter and some other parts, for instance, if the installation is buried, I can have a configuration to put 3 meters, because if it's buried, it's not a problem for acoustic problem. You can have problems, friction problems, but it's not acoustic problem. But if you use a good material, you can bury it and put 3 meters. You understand? I can use this criteria, and then another criteria. Let me put here houses, and then when I'm going to put the pipes in the house, like for instance, so to not have because you have to relate this with the maximum, more velocity, bigger pipes, so more expensive, that you can analyze also in the program. But we can, like changing this, I can put this criteria for the way in the houses, and this one for buried installations, for instance. Can we use the model for large infrastructure projects? Of course. You see a building of 25 floors, but if you have a good computer, not like mine, you can do wherever. Normally, when more information, bigger computer, you have to have bigger. I have a E5 with 8 gigabytes of RAM, memory. If you have 16, you can have the double of 25, and you can have also to use, if you use the simultaneity, you can use it forever or wherever you want. We have now a client that is using this program to install other in other kind of, not houses, other kind of installations. Okay, so for instance, The thing is, the hydraulic systems is the way of calculation is the best, the better, the more precision formulation is in the program, so you are going to see. By using these models, can we identify the leaks or bursts during operation of the townships, as these all pipes are buried below the ground? I don't understand the question. Sorry. Can we identify the leaks or bursts? Here, my English is very bad to understand this.
In my
During
sorry, I think he's referring to some kind of explosion or something like that due to the pressure.
explosion,
I don't know. I was looking for that. Maybe he can. That
maybe
is bro.
what we can control, what if his
Yes.
explosion, if his problem is
Or broken. If the span is going to broken, I don't know if he refers because it has too much pressure. I don't know. Maybe he can explain it.
if we talk the pressure of the installation where the installation is going to be, we can work with minimum. I'm using this, but it can be wherever you want here. Okay, but we can. The program will warn me if we are with the too big pressures to the material that you are using. So the program will do this advising or these warnings when you are passing some pressure on your installation. The program will have graphic analysis of all the pressures in all parts on all parts of the installation, and you can analyze this, and using this and using the proper material, you can establish a consideration if it's that you're concerning. Okay, you have to use pipes that can allow you the maximum pressure that you put on the configurations. I don't know if I answered the problematic or not. How about the pipe flow velocity calculated in plumbing? Can it be exported? Exported, of course. The program will export it, and you're going to see. Let me finish. Let me show you a little installation, and you are going to see the velocity calculation, and it can be exported in justification, all the justification of all the installation. I don't know, Maria, if you did the
Yes, good.
the
Open water equipment. Yes, I'm exporting now. Okay.
Okay. So Maria is still working in his house doing the
Yes.
water equipment. For now, I'm not having the water equipment, but Maria, with our interoperability, is going to make me the water equipment, so I can receive the water equipment and having it to water supply and wastewater installation.
Exactly. We try to do this like in
Yeah.
the real, like in real life. That sometimes maybe I can send him the architectural model, and then
Exactly. It's
afterwards
so,
adding new elements, or it's not always in the same order. So it could be in real life that I say now, Paulo, I have completed the sanitary appliances.
okay.
You can upload it
So
now.
is not I can start to work, but and then I'm going to have warnings that there are more information on our project. It can be structure, it can be Bhaskar was telling CP acoustic with the solutions for our walls or for our uh, architectural solutions. No, so we can receive an in this interoperability. So when Maria is doing that, and when he stopped, I'm gonna actualize this, but I'm gonna explain the program in the easy way. So the general options that we saw on the beginning, they are here. You can change it, you can update it, you can use wherever you want to establish the maximum pressure, the maximum velocity, criteria for having more loss of span in the worst cases. So the program will optimize our pumps, our installation, our hydraulic installation. We have here the material and equipment that I advise you that you did. You saw what material that you are using or that you have around, and you configure the technical information. It has to be there, so the program will calculate with your materials and your criteria. Okay, so the program is going from a bigger criteria for until you can, like I told you, I can use a criteria for only the part of the houses, and other criteria for the buried part. Okay, let me show you. Then when Maria gave me the
You should
water,
have it, Paulo. Maybe you can check if
you
you, yes, because yes,
let
yes,
me
yes.
check. Okay,
Please.
it's here. Okay, I have here now. Maria do it. It put the new. So I'm going to update my information, model information. So I'm receiving, and you can see how this works with the flow, the workflow. So now I have consumption types. So then I stopped here, and then I have next step because I have more information on our project. So the toilets, I'm going to establish that the toilets, it's not necessary that all the toilets. And here we establish more or less the ones that I have more, but we can then establish that ones respond to a criteria and others respond to another criteria of calculation. Like the question, I can have ones with maximum pressure and others with the other pressure. For instance, if I use a flushing through, I have to have more pressure, minimum pressure. So I have to change the criteria of some ones. Some of them can be flushing through, and I have to have minimum pressure, bigger minimum pressure than a normal system. Wash basin, I'm going to put wash basin, and now I'm establishing from architectural, I'm putting technical conditions to this. You see, now I'm seeing what Maria was choose to put. Let me show you here. There it is. Nice, Maria. Nice architectural.
Thank you, thank you.
He chose a good ones. They are beautiful. But now
Exactly.
this is transformed on a criteria. You see, this criteria, the ones that is using, you see, the water system, the program will be able to achieve 10-meter water column on this minimum and maximum this one. Okay, I established this, and the wash basin that Maria was very beautiful to put. So I put all the conditions here. Okay, so you have
Exactly. I'm interested in
yeah.
the design, so it's
You only design. I'm preoccupied with the engineer's problems. So
exactly,
I have to
exactly.
be careful with the hydro mixture that I'm gonna use. If I'm using an installation for a hospital, maybe I have to put more pressure or more flow. I don't know. I have to analyze this. Okay. So the program will establish in this point what the criteria that I'm using, the minimum diameter that this hydromixer has to have. Okay, I'm only preoccupied with engineer problems now. Maria with architectural, and me with the more important problems.
Exactly. I'm sorry to interrupt Paulo, but what could happen, just an example, okay? Imagine that Paulo tells me, well, the thing you said, I think we need that the position of the element is different because I think it will be problematic for the hydraulic installation. So what I can do is change the position of the elements in open bins and open bin water requirement and export again. Okay, so this
Okay.
is the flow. I can make changes and then all the programs that supplying water systems and supplying sanitary systems will have the new position of the elements.
It's important because when I work with projects, it's often very usual that the project will have changes in these steps, no? So it's important
Exactly.
that you have to have this interoperability, so you can work in the changes in the right moment, you have all the control of the project. Okay, so
Exactly.
I'm putting the real point of engineer programs that CYPE does is to have a flow. Let me explain. This is very important. To do a calculation, we can do a basic calculation or a calculation based on what you see, but so the program can do the automatically calculation of all the installation, we have to have initial point, can be a supply connection or can be a stop valve that we indicates that is the initial point. This is very important, and the consumptions, the final point. If you connect the supply connection or stop valve from initial point to the consumptions, when we have this one consumption only, for instance, we can start to do calculations. So the program will calculate the flow, we calculate the simultaneity that we have to use, we do sums, or it calculates all the flow, the continuous of the installations. He is going to have all of these concernings, the program. So the thing is, you see these logs, you never, my advice, you never log before the program do its calculations. You have to make the installation, make the drawing, the first concerning, the very important concerning this, you draw a good installation with the courses, little courses, or the minimum that you can do. And then the program will calculate these parameters where the log is. For instance, if I don't have log, the program doesn't know how to calculate these parameters. If you have log, the program will calculate. Okay, so you can, after the program do these calculations, you can lock it, but before you don't have to lock it. Okay, I don't know if you understand or if I'm talking okay, Maria.
Yes, I understood it. Let's see if somebody has any question. But I
No,
think you
just
mean,
for my
yeah.
English before and
Yes,
after. And
yes. Is
okay,
what he
so
said. Yes.
I'm putting now, you see my symbology for a supply connection. It can be other kind of symbology. I am putting a cold water meter, a water meter. I'm putting in the here with the flow that is going to have the pieces, the accessories, so we can study these parameter with the loss of span of this accessory. Okay, the program will study it. Then what can I have? The stop valve, like I was told in before, we can have a stop valve for start of the installation, of end of installation. The important thing is to have a start of the installation well decided and end of installation well decided. For now, I have the supply connection. I can put a stop valve in here, for instance. What sorry. And then one thing important is to establish more the weight of the installation on all the floor. Maybe we have different ways. I'm going to work with this. For now, I'm going to put the weight of the installation 3 meters. Okay, 3 meters. Okay, so then I'm going to work more the installation. For instance, I was told that I'm going to use this criteria for buried pipes. So I'm going to use here, and now I'm drawing. Okay, now you have here ways of doing orthogonality, polar tracking. You have ways of using, like if you are used to CAD solutions, you can use BIM, like you are seeing a BIM program with the normal CAD solutions drawings. You see, I'm connecting the stop valve, and then I put the criteria for buried. Okay, this one for burial, I established that. And now for inside of my house, I'm going to use another velocity, another criteria for the velocity, so I can have less problems of acoustic and pressure too. If I down the velocity, I have bigger pipes, so less loss of span. So now I have already put it, this is the easy part, but not so easy because you have to study it. It's very important that we have a design well done, so we have loss of span, less loss of span. Okay, so I have already the cold water design, so I can calculate, because like I told you, we have an initial part, a final part. So here you see is warning me. The program can establish the cold water pressure and design. So I can have here, I need in this installation 15.07 meter water column to have here 10 meters, or 1014 in this case, or 10 in the worst case, in the worst span. You see, the program will put worst case of spam, and here it guides you to the worst case of spam to have the minimum pressure where it's needed. So now I have warnings, like I told you, I need water heater. I need to establish a water heater. So I'm establish a little one, a normal one. I can establish here the consumption, the demand, the daily volume, if I'm going to use a storage one, but I'm going to put one that is instant water heater, for instance. So I'm going to put here, and then what I have to have. So inside of my house, let me put from here, I have to connect water to them, cold water, and take hot water outside, and having, I'm sorry, I'm using it in the first floor. I'm putting in the first floor all this is going to be like in the first floor, all I can have a vertical pipe, and the real thing is that in ground floor we have the
connection.
supply connection. It's not a problem, because in this way you can see that in the first floor, and maybe in this part of the installation, we have soil. In the other part, we have not soil. So I can put the water supply wherever it is, if I have soil or not. If all the floor was in the ground floor, if was this, I have to put the supply connection on the ground floor, and then with water, with the vertical pipe, I take it to the first floor. In this case, I put all the installation you are going to see on the first floor, but I'm going to calculate. See, you see here, is warning me I don't have the proper water heater for this installation, for the simultaneity that I have in this installation. I fix my problems, and now I need 1735 or meter water column. Let me see what I did here. Wow, it's worse. It's very bad. Let me show you. Because I put like I told you, this part of the installation has to have buried in the other part in so it's very easy. So now I'm gonna check my logs. So I'm putting this in 0, so it has to be in the ground. For instance, in this part, also in the ground. So now I check my and block my installation. Now I'm going to calculate again, redraw, and we have here the installation. Like you see, is a line, but I can put in. It's important that if you're gonna export, take the single file and put the right, okay, the right
dimension, with the real dimension.
With the real dimension. For instance, if I put here in my original pipe, in this case of hot water, I can establish a thermal insolence, or take it off and study, for instance, in graphic analysis, the thermal insolence thickness, the linear heat flow, you see, is losing a little bit only, but if I take off my insulins, for instance, in this case is this one, if I take off and I calculate again, you see, I'm losing a lot more of energy because I'm not is a little installation, but I'm losing a lot of energy. You can see the importance of many things on water supply installation. For instance, like before, we are talking about velocity, no? So the velocity, you see, I have problems. The 2.26 meters. Let me take off this to see it better in single filaments. You see, I have problems there. I don't know why because what water, I didn't align what water to 1.5 meters. So let me go to what water and put, no, 3 meters inside of the house. I don't want it. I want 2 meters. Okay, so let's calculate again. You see, 16 is not enough to establish another velocity. So yeah, okay, now I have maximum 1 meter 42. You see, in the right, is this a little installation, but in the big installation, you can make this kind of analysis and take these questions. So the design criteria, like I told you before, we can analyze. We have Darcy Weisbach along with Colebrook White. So we have the best precision calculation, motor calculation. So we have the dissipated calculation, okay, and we can have also the potential.
The power, very powerful.
The power of the equipment production we can calculate with these norms. Okay, we have the simultaneity that we established to use, and this is our project. If you change anything of this, the program situation is what you see is what you get. All of the configurations that you made, all of the text that you put it, for instance, I put horizontal pipe houses. This is my rating. Okay, this is my criteria. So the criteria that is going to be on the document is going to be what I wrote. So what you see on the configuration, what you configure, what you put on the options, there's going to be what you get on the justification of your project. You have the results, the checks that we can, you see, you can put, you see maximum velocity condition accordance to 5.5 of British standards. Maybe here I can put, well, I improve in certain kind the maximum velocity at 1.5. You see, this is not according, is according British standard because it's less of 3 meters, but I can put there more text to justify that I want better comfort, less loss of span on my installation. Okay. For instance, the materials that I'm going to use, the quantities that I don't talk about, but you have here bill of quantities that what I only have to do is this one, is this, okay? And in this case, I have now all the pipes, the bill of quantities, and I can go from here, for instance, there. You see, you can go the water equipment, okay, and you can establish prices and have the budget, okay. So very easy to use. So in this case, you can have now in your document, you can have the quantities also, no? And you have here the quantities on this project, and you can make a document, sorry, I don't know, memory or whatever you want, and put design, result, checks, materials, quantities, in price no. So I want to make a document for the justification, sorry, is because the units I use, sorry, some things of the, sorry, I use a units that is not allowed me to take in the projects. So sorry. So, things of direct explanations. So the thing is, I can do the reports, I can have the plans. Okay, so I can design our plans and put symbology. I can use K-by buildings or K-by drawings. Okay, and have plans very well done. Okay, so the first plans, like I told you, then when we export, we can use another programs to achieve better detail on our project. Now I have the case, the dimensioning, the same thing. What you see is what you get. If I go in here and I take off these dimensions, I can take it this from here and tell that this is here. Okay, so what you see, you are doing the design, making the reports and making the plans at the one time. You only have to design, to draw, and the program will design and will establish the documentation, the justification and the plans, and you can now export this information with all the documents that you want to the project. Okay, so we have little minutes, so I'm going to show you the part of wastewater. Is more or less the same. I use more time maybe for the other, but like Maria told at the very beginning, if you understand the program, you are going to understand the other one. There are more questions. Thanks so much. What the recommended system requirement for applying the software smooth? It depends where. It depends on the. Like I told you, if you are going to do a 25 floor installation, maybe you have to have a better E5 and better than 8 gigabytes of memory RAM. Maybe you have to have this. Okay, if you have less than this, projects less than 25 floors, maybe you can have my computer. It's okay to work with it. Okay, and the thing is, if you want to interoperate with many people and you're going to have many information in these big projects, big program, big computer, better. Okay, but for me, it's sufficient, more or less, the E5 with 8 gigabytes of RAM. Okay. Okay, so I'm going to now again to the model that he creates now, just now, and I have more information now. I have the water system. I can additional import it. I have the open BIM water equipment and the initiator. That I'm, you see, more information on the cloud, more information on the project, more information I'm going to have to do the water systems. In this case, the wastewater installation. Okay,
Exactly. We're very concerned about the consistency, so everybody we can see everything in 3D.
Okay, so the general options in this case, I'm going to import again the British standard. This is the European norm, and in this case, like I told you, it's very important to use the materials that we have that we are going to work at the end. So to have in this case, the Manning coefficient and PVC in this case, but I'm going to put also the axis to give you an example with the manufacturer open BIM program. Okay, so in this case, you see the same thing. This is the parameters from the norm, the slope, the tables, additional checks. In this case, I like it always to have the hydraulic analysis. You can see here that we work with the Manning Strickler. We work in Dawson and Hunter for water. For rainwater, we use Hill Heaton. So we are using the best formulation that it is available on all over the world. Okay, and it's accepted all over the world. For instance, like I was talking before, the excavations. If you want, you can establish here. It depends on the soil that we have. We have to have inspection boxes with a perpendicular. I don't know, perfil, how do I say?
Section, a section?
Section, sorry, the section, yes. The transversal section or the longitudinal, how do I say it?
1 second.
I can put here for soil
The
some
same
kind of
way,
soil.
longitudinal or long cross section view.
You have to establish this one to then I have the long cross installation. Okay, so I can establish here, and the program will calculate the volume of excavation needed for your installation. It can be a little installation or a bigger installation, and can be a lot of money going within this volume of excavation that you need. Okay, so it's important that you can establish these sections. Okay, so I can analyze these. I'm not going to waste waste many time. I'm going to put now the toilet, wash basin. Again, this is information that we establish on general options. We import this information. Okay, and now we establish the sanitary systems. In floor 1, in this case, I can establish first the vertical. Sorry, I didn't establish on the criteria that I'm going to use. For instance, I'm going to use in this case this kind of pipe, this manufacturer that I told you before. In this case, also this kind of pipe, so it can be in the reality using the same kind. And the vertical pipe, let me put this one. Okay, it doesn't matter. For water, okay, and you have to, you see, configure this, export your configurations to use in other installations. Okay, so now I'm drawing. I'm going to drawing now. You see, I established this material. I don't mind of the diameter because it's going to calculate. But first of all, I'm going to put I am putting 110, but I don't lock. Okay, it's only to see it. The program will tell me if it is okay for this installation or not. So I'm going to put here more or less from here, from the roof to the ground floor. You see, now you are going to see a vertical part of the installation. How can you do it? And now only drawing. You see here, polar tracking at 45 degrees, more or less is the pieces that I have on the real life, on the manufacturer. So here, the same thing, you see, I have orthogonal and polar track, okay? 45 degrees, and I am showing you that I have these pipes on these accessories on the real life. Okay, for instance, here is gave me the installation depth, so, of the depth of the installation, the first depth, because this is gravitical installation. So the thing is that it's going to start to 0.5. I'm going to put, for instance, 0.35, for instance, 40. And we'll start in 40 and it's going to be down. The program will calculate this slope to the installation, will work it out. Okay. Here I'm going to take it to the vertical, and then the ground floor. I'm going to put a inspection box, intermediate inspection box, that the program will calculate also the depth of this. In this case, I'm going to put main drainage pipe. I don't know what kind of criteria I use there. Sorry, this is important. In this case, is important that I establish. Okay, discharge connections. So for instance, I made a mistake. It's very easy. Let me take this that I correct and take it to here, and also to make a connection. And I changed it already, all the pipes to the criteria discharge connection. Okay. There are many more tools. You can automatize this. Okay, you can put horizontal pipe. If it is a discharge, it has to be a discharge connection from this discharge. But this is for another seminar, another day, because it's many information. To start using it this is the necessary information. Okay, so for instance, what we need also the same. You have to have the supply connection point. It can be whatever supply connection it is, okay, and the discharge. In this case, the discharge is the first point, and the supply connection on the connection on the street, you know, it's the end point. So it's very important. So the program can calculate all the tree of the installation from the beginning till the end or our installation, and he's going to calculate the flows and all the things. Okay, the minimum diameters is calculated. In this case, is very easy. Hydraulic analysis in this, okay, is calculated. Is already calculated. I can remember what you see is what you get. I can take off information that is not needed here. I can take this from there. I can put that the vertical pipe is there indicated, okay? So the ground floor I have already, you see? Let me take this off to there, for instance, and analyze what is happening. This is the important thing. We are using the standard and we are using the hydraulic analysis, and you are applying the real pipes, you know? And then the same way you can, sorry, let me do the bill of quantities so you can see it. The same way I can delete and create, importing all the bill of quantities wherever you are there. Wash basin, the discharge connection, you see the discharge is this 3.70 meters of this kind of discharge. Okay, we have this. We have the hydraulic analysis also, if is the flow, the simultaneity, the drag force, if it is needed, if you are going to use slopes, very less lower slopes, it's important to use a calculation of drag force. To use drag force, the only thing you have to activate all of these. You have to activate on hydraulic analysis. I have to put minimum drag force, 1 Pascal. So if you are using for needed for having, if you have a big project and you have to excavate the less possible, you can have this kind of comproval. If the drag force results okay, so we have auto cleaning installation, for instance. So the program is very powerful in this case. Okay, so you can use here the field level for example. It's important in this case that the norm, like I show you, is the maximum the norm permits in this criteria is 50%. So the program is establishing the 50% minimum. Is exactly, in this case is very easy, but in big cases, if you, like you see in the 25 tower floors, you can use this, okay? And you can see in all the things put it. Now, the same thing, I'm repeating myself, the criteria, that is what you see is what you get, okay? The results, the checks, okay? You can separate, separate wastewater from rainwater. For instance, in all Europe, more or less, in the European norm, is obligatory, is important that we separate rainwater from wastewater. And also you can make not only rainwater from wastewater. In wastewater, you can have gray water, black water. You can separate many kinds of waters that you have, okay? So here you can make your own documentation. Again, in this case, I only have wastewater in quantities, and also I can have here now the document with this index and with all the justification to do a proper project. Okay, so the same thing for the plans. You have many information. Also, we have a scheme of the vertical pipes, where from where to where is going to be the vertical pipes. Okay, you have many information. Don't look many or the organization of this, because it's the first organization. We can move it, you can edit it, you can export a DWG file and work it out. You can make, for instance, drawings with other kind of DINA, ANSI, wherever. You can configure all over the program. It can be personalized, okay? And in this case, I export my wastewater installation. I'm passing the time now, but it's only to see that we can convert on the real project now of Open BIM Aliaxis. We can convert this flow, these calculations on real pieces, on real accessories, okay? Let me see one moment if I can do it. I see that you can also I'm having problems, I think, with internet. With my net is not valid. I'm having just at the end. I'm having problems to upload the information. Okay, so say I'm having problems with my internet connection. So the thing is that you take the general idea of we can do with these programs, the powerful they are, that you can start easy from an easy way to do installations. Let me see. No, I cannot do it. Sorry. Let me see if I can restart the program, but we are on time. I'm so sorry. I wanted that you saw the all steps in the live session, but I'm not. I'm having problems with my connection. Let me see if I can start again. Let me see if I can recover the. Thanks a lot to you, Bhaskar. Thanks a lot to everyone to be there. Sorry for all of these technical issues that we have. I hope this is well recorded and we can you can see it again with more time, all the thing. So, for instance, in this case, I'm going to import sanitary systems. I recovered a little bit. In this case, we have the catalog for Spain or for Italy. In this case, I'm going to use Spain, for instance, to use a material. And so the 3D, I have here the architectural model and the pipes. These pipes is the ones that come from the project. Okay, so in one click, I can convert this model from the project from being only a pipe to a real catalog. You see, a real catalog with the reference. In this case, 40 we have. In this case, we can work with many lengths. So the program will choose the best length for each part of the installation. So here we convert the pipes that we already did. So I changed it here, sorry. And let me take off this. I change it. It's very easy. I can go again at the pipe and convert only this pipe now to this kind. Okay, it's very easy. And now I can create the accessories. Okay, the elbows, the tees, and will be created. Here, for instance, I cannot create it, but it's very easy. For instance, I go there in the project and I see that is a change of diameters. If I apply here a point and I establish here that is the same diameter, 50, for instance, now I can block because it's accomplished, okay? I can you see, I'm accomplished. The program will give you the first solution and the better solution to have minimum slope to your installation, because the slope is important for excavation and for the minimum free height on your floor, no? So I calculate again, I export again. Let me see if I don't have many problems with the internet connection. And he's going to upload it. Okay, so I have a new configuration. And here you see the program tell me, oops, there is changing on our solution, no? And there's a change. So I'm going to import again is with changes, okay? In the workflow, it's very easy. The important thing is that for me is I can change it on, you see, if I can change it on the project where the calculation are, so I can assure that the criteria is well done. You see, the program now is different there. So I can erase all the pipes again and rearrange these to have new pipes, you know, and now I have a new pipe there. Okay, for instance.
Exactly. Paulo, sorry to interrupt. Sorry to interrupt. Just a little comment. As he is doing this, I'm getting the wastewater installation project also in my account. If I check my project, I see everything he's done. All the files he exported are in my project also.
Okay, so this is important. You can manage it. You can review all the installation to have all in account. You can fix all, and in one click, you're gonna see the elbows, the T's. You see. For instance, there's a reduction eccentric increaser. In this case, there's a T. You know, a real T. In this case, this is a real T. Elbow with the 45 degrees that I use on project, you know, and with the real slope that I applied to achieve the hydraulic conditions. Okay, so I have it all here. I can see if it is, you see, this is not okay. Why? Because there is no elbow with 90 millimeters that goes to 110 millimeters. So I have to work it out, or I have to go in the project, take it to the diameter, and so on, so on. Okay, so sorry for the time. I think I'm out of time. Thank you so much for all to being here, to listen me, and to resist all of this webinar. And I hope I see you again in new seminars, new webinars. Sorry. Okay. I don't know if you want to tell something else. Tell something else more.
Well, in my case, thank you very much for attending. Again, my apologies for the technical problems I had at the beginning with the internet connection and the GoToWebinar platform. But I think that we managed to do everything we had in the schedule. And anyway, if you have any doubts, please don't hesitate to contact us in our email. I wrote in the chat the address is support@cype.com. Okay, but you can check it in the chat. And we're available anytime. Okay.
Okay, so thank you all of you to join us today. And if Hong Kong client want to purchase the site plumbing system, you can ask us. We can help you to apply the CITF funding, which will support your funding to purchase the license. So yes, welcome to ask us any question. Yeah.
If you have any questions, please feel free to contact us.
Yeah.
So we can help you to solve the problem. If not, then we'll go back to Paulo or Maria. Yeah. Okay.
Thanks
for watching.
Thank you.
Welcome.
Thank you.
Goodbye.
Thank you.
Bye.
Bye.
Bye. Bye.